Good morning, students. Welcome to the class of Technomathematics. So today we will be solving one question where it's given that a car is going on an inclined plane. Okay. So it's mentioned that when an automobile moving with certain speed reaches an upward inclined road. Okay. Let's say this is the upward inclined road, right? And this inclination is of 30 degree, right? Now the car was, let's say it's coming from here, right? It's coming from here, and when it reaches the inclined plane, it it was moving with a speed of 36 kilometer per hour, right? So here you can see 36 kilometer per hour is the speed of the car at this point, right? Now it's given that when the automobile moving with a speed of 36 km per hour, this car is present over here. Okay, at this point the speed of the car is, this velocity is given to you as 36 km per hour, right? Now the slope, the inclination is of 30 degree, and its engine is switched off at this point, right? So at this point, let's say at point at A, that means a start of slope, starting point of slope. What happened? Engine of the car is switched off. This is switched off, right? So the engine of the car is switched off at this point. That means whatever the velocity on which it was running, that velocity, this 36 km per hour, will be the initial velocity for the section, for the movement which is on the slope. So this will be the value of u, right? When we consider that at what distance, after traveling how much distance, the car stops. So let's say the car is moving till this point, right? And this point is B, and the car reaches over here, right? Till this point the car reaches and it stopped. So the car traveled from A to B, right? So let us see what are the forces acting on this car at this point, because we need to consider that we need to find how much distance will the automobile move before coming to rest, given g equal to 10 meter per second square, and it's mentioned that the coefficient of friction is 0.1. So let's say at this point just draw the free body diagram of the car and see how much forces are acting on it, right? So this will be mg, right? This will be mg, the weight of the car, right? And if this angle is theta, this is 90 minus theta, and definitely if this is 90 minus theta, this angle will be theta, that is 30 degree, right? If this is theta, right? Now at this point, let me zoom it a little. I think it's better visible to you, right? So at this point, this mg, the component of weight mg acting along this direction, will be mg cos 30 degree, isn't it? The base, the base component over here, and if this is the resultant mg cos 30 will be acting over this one, the along normal to the plane, normal to the inclined plane towards the earth, and the component which will be acting here, because this mg, if this is the resultant vector, this is broken into its two component, mg cos theta along the base, and this is perpendicular, which is mg sin theta. So this will be mg sin 30 degree, right? So these are the, this component of weight is broken into two parts. And let's say if there is a friction, then friction will be acting in which direction? Let us see. The car is stopped, the engine is stopped at this point, and car keep on going, and stops at this point, right? We are going to calculate this distance, let's say this is s, right? This we need to calculate, that after how much distance the car is stopped, right? Now we can do one thing. At this point the friction is also acting, because that friction is only the responsible cause due to which the car is stopped at this inclined plane. If that friction was not available, then definitely the car will be continuing on this slope, right? So the friction will be acting in which direction? Let's say it will be against the direction of the car, definitely. If this car is moving upward, this will be against the direction. That means the friction will be acting into downward direction towards the start of slope here, because this is stopping the car, this frictional force is stopping the car, and this force is frictional force, let us represent it by a small f, right? So when we see the component of forces acting over here, and let's say if this is the driving force and the car is moving with an acceleration, basically that is retardation, then we can say that MA, the component upward, will be equal to F plus mg sin theta, isn't it? The frictional force plus mg sin 30 degree, isn't it? Mg sin 30 degree. Now this is the frictional force, this is the frictional force representing with a small f, and this frictional force is equal to mu, that is the coefficient of friction, into the normal. And what is the normal? The normal will be acting into this direction, right? That is always perpendicular to the plane, and this normal, let's say this is n, then we can say that if mu n was is the frictional force F, then mu n plus mg sin 30, that is 1 by sin 30 is 1 by 2. So this will be written like this is equal to m into a, right? Now here first we find the a, that is the retardation. So just put up the values first. So m into a, it's also, no, m is not given to you over here, right? So what we can do, just put up the value first. M into a is equal to mu. The value of coefficient of friction is given to you as 0.1. So it will be 0.1 multiplied by n. What is the value of n? N will be equal to the component of weight acting downward. This is mg cos 30 degree, right? So mg cos 30 degree is equal to n. N equal to mg cos 30 degree. How? Because mg cos 30 degree acting downward and normal reaction is acting upward. Okay, this is normal reaction is acting normal to the plane of movement, normal to the inclined plane, right? You can see this is 90 degree, this is 90 degree, right? So that's why this n is equal to mg cos 30 degree. This n is equal to mg cos 30 degree. Now, hi Ashlyn. So this, just put up the value mg cos 30 degree, mg cos 30 degree, right, plus mg by 2, mg by 2. So here you can see m of LHS will be cancelling m of the first component of RHS and m of the second component of the RHS, right? So we are left with what? We are left with the value of A, which is equal to 0.1 into cos 30 degree. And what is the value of cos 30 degree? It's root 3 by 2. So 0.1 into root 3 by 2, which is the value of cos 30 degree, plus g by 2, because m is already cancelled. So the value of g is given to you as 10 into the question. So 10 by 2. So this will give you the value of retardation. So let me, yes. So the value of A is calculated as 0.1 into root 3. The value of root 3 is 1.732 divided by 2, right? Plus 10 by 2. 10 by 2 is 5, right? So this will give you 1.732. This will be 0.1732 divided by 2 plus 5, because this decimal is, after this decimal one numeric is there, and after this decimal 3 numeric. So in the product we should consider 1 2 3 and 1 4, 1 2 3 4. So we put decimal over here. So 0.1732 by 2 will be 0.1732, will be giving you 0.2 into 8 16, 30 into 6 12 to 6 12, 0.866, 0.866 to 14 to 16, 17 carry 1, yeah, that's fine, plus 5. So this will be giving you 5 point, this will be giving you 5.866 meter per second square. So basically this is the value of A, acceleration on the slope, and this is into the form, this acceleration is the maintained by the movement of the car or the velocity which is already this car attained, that is 36 kilometer per hour. This due to this velocity, this car reaches over this point, right? Reaches over this point. Now since the value of g was in meter per second square, so that's why the value of A is calculated as 5.866 meter per second square. Now here we have certain values with us, which, that is, what are the values with us? We have u, we have the value of u, that is the initial velocity, that is 36 kilometer per hour. So this is basically, you can see we have mentioned it's u, right? Because this is the starting velocity when the movement on this slope started. This will be the initial velocity u, right? So that is equal to 36. So I'm writing the values over here. So rather than writing over here, I can just mention it over here, right? So here the value of u is given to you as 36 kilometer per hour, right? We have calculated here the value of acceleration due to gravity, that is 5.866 meter per second square, right? Since the car is switched off at the starting moment on the slope, definitely due to this acceleration only, the car will be moving on the slope and it is stopped, right? The car at this point started and engine is switched off at point A and it stopped at B, as we have discussed into the figure above, right? So this distance is the s, this distance we need to calculate, right? What is the value of s? So using the formula, definitely at this point, if here we have initial velocity u and here we have final velocity v, right? But the car is stopped over here because the engine was stopped, and with the present momentum at this point the car is moved till this point, but definitely at this point the car is stopped. So the velocity at this point on the slope, that is the final velocity, which will be equal to 0, right? And here the starting, the car was moving on a speed of 36 km per hour and engine is switched off. So the value of u, the initial velocity, is known to you. Now use the formula v square minus u square equal to 2as. Why we are using it? We are using it because we are knowing the value of v. Sorry, it's 0. Yes, that's why we are knowing the value of v, we are knowing the value of u, we are knowing the value of a, which we have calculated, right? So the value of s can be easily calculated, right? Hi blue blood vessels, hello, how are you, good morning. So putting up the value 0 square minus u square, so u is 36. So you can see it's kilometer per hour and it's meter. So you need to convert this kilometer into meter per kilometer per hour into meter per second, or this meter per second into kilometer hour. So let's convert this because I think this is easy, right? So good morning blue blood, how are you? So putting up this value, this is 36 kilometer per hour. Just multiply, just to convert this kilometer into meter, multiply it with 1000 into the numerator, and in the denominator it's hour. So it will be converted into second as 60 minute into 60, right? So this is converted into meter per second when you multiply it with 1000 by 3600, right? So great, nice to see that you are good. Yeah, be connected, thank you so much. So putting up the value of u, it's 1000 because kilometer is converted into meter, and 60 into 60 is into the denominator because hour is converted into second, right? This multiplied by, what is the value of u? 36, right? So this whole square, isn't it? Because u square is equal to 2 into a into s. We have not substituted the value of a. So definitely you are good. Yes. So to calculate the value of s, we can see it is how you can just cut this 0 from this 2, right? And 6 into 6 will be 36. So 36 will be cancelling this 36, right? And we are left with 10 square and when we need to calculate the value of s, just bring this 2a into the denominator of LHS, right? So this will give you minus 100, 10 square is 100, right? This is 100 and divided by 2 into a. What is the value of a? Is 5.866 meter per second square. 5.866 meter per second square. So this will give you the distance in meter, and this is the value of s, right? This is the value of s. This is the same s, right? So when you calculate it, you get the actual value. This is simple calculation, right? So you get the value of s. So s is calculated as, from 2 you can cancel this 150 times. This sign, don't you can ignore this negative sign, don't get confused, because this is again going on the slope and this is against the gravity, right? So that's why it's negative. So when you consider the magnitude will be only this one, 50 by 50 by 5.866, right? So if you consider this as 6, rounding off, right? So from 6 we will divide 50, so it will be coming as 48, it will be coming approx close to 8.2 meter. So this is the value of s. So the value of s is calculated here, the value of s is calculated, and this is 8.2 meter. This is close to, okay, so I'm using this sign, this is close to 8.2 meter, and this is our answer, right? So I think if you will be finding this and discussion and this solution useful, and I have explained each and every step in very much detail to you, so definitely it will help you. And at this point of time we need to wind up, and you can go through the each and every step, you can easily solve such questions, right? This will help you. Thank you so much for watching. Take care. Bye. See you.